Hi guys, welcome to the 37th video of the Love Babbar 450 questions series. So we have finished with array, matrix and strings. So searching and sorting, it is taking some time because I have some work, I have college work, and this semester I don't even know the subjects names properly. So I need to first find out what all topics are there. I have my tests approaching. So in the upcoming videos, maybe you will find only one or two questions per video. Please don't be angry. I'm really sorry for that. Please support me and we shall solve it. We shall complete it. I won't stop, but I cannot guarantee more questions. So please stay with me and I'll put the link of the playlist in the description, and also this you can check on Code Chef. It is becoming very trending now. So you can check it out on Code Chef, and on Code Chef I've put my playlist also. So all my videos you can see it there, or you can go to my channel also. So today let us solve this famous problem, aggressive cows. So there is a farmer who has some cow stalls. Uh, they are at positions x1, x2, so on, xn. So there are n stalls. He has C cows and they have become very aggressive. So in order to prevent hurting, he wants to place the cows in all the stalls, not all the stalls, sorry. He wants to place the cows in such a way that minimum distance between any two cows is as large as possible. And we are asked to find the minimum largest distance. So when you see this problem for the first time, you will not know which concept only it is, first of all. So now it is written over here, it is binary search. So you will know it by looking at this. But if only this question is asked in an interview, it will become very tough for you actually. So these kind of things you should know before you enter an interview, because on the spot, I don't think you can solve it. It will be very tough. So this problem is done using binary search. One hint you can get by binary search is they're asking some largest minimum. They're asking you to minimize some distance, maximize something like that. And we have to, place the cows and we have to search for something. So it is a binary search question. Whenever searching comes, it is definitely binary search. If the constraints are too high, otherwise you can do linear search also. So now they have given us something. So they have given N and C and the input is like this. So N and C and the stall numbers where the stalls are located, that is given. So let me just revise all you people once. Let us make a revision. For binary search, what all we need? For binary search, first thing is sort array. Sort, instead of array, I will say search space. So search space should be sorted. Second is find mid value in the while loop. This is all in the while loop. Third is some check condition. Some condition will be there according to the problem. According to this, either move right side if you want to maximize or move left side if you want to minimize. So this is the general way you do binary search problems. Okay. So you should know this general method. How is it going to help us? So in this problem, what are we supposed to do? We are given n stalls. We are given C cows. We are given C cows, N stalls and C cows. So let us take the test case example here only. What are the positions? So the array is, so position of the array is what? 1, 2, 8, 4, 9. Let us sort this. First, let us sort this. 1, 2, 4, 8, 9. Okay. Now we need a search space. search space in this problem is not equal to array. Search space is not equal to array. What is the search space? So first step is sort the array. This is step number 1. Now let us go to step number 2. So in step number 2, we need to find a search space. So what will search space be? Basically, what is lower bound and what is higher bound? If you observe the problem carefully, lower bound will be 0. If you place two cows, C1 and C2, in the same place, then minimum distance becomes 0. And maximum distance will be the upper bound, sorry. So the upper bound will be maximum distance minus minimum. Maximum stall coordinate, minimum stall coordinate. We have sorted the array, right? We have sorted the array. So largest distance can be what? I will place it in the first stall and I'll place one in the last stall. So that will be the maximum distance. So this is our search space from 0 to a of n minus 1 minus a of 0. This is our search space, okay? So we have got search space now. Now what we should do? So now we need to write the check condition. What is this check condition? First, we need to calculate mid value. Mid value will be L plus H minus L by 2. Okay, so mid will be this. Now, what is the check condition? Our check condition will be for this mid value, can we place all the cows or not? So if the count of cows is count, can we place count greater than or equal to given number of cows such that distance between each cow, say cow 1, cow 2, cow 3, so on, this distance is at least mid. This distance should be at least mid. Can we place cows in such a way that distance between any two cows is at least this mid value? That we have to write a check condition. So now, suppose we are able to place. Okay, so what does it mean when I say we're able to place? There is a search space LH and some mid value. And for this mid value, this check condition is true. That means we can place all the cows such that the adjacent cows distance, the distance between adjacent cows is having what? Mid value. It is having a distance greater than or equal to mid. The distance between, the minimum distance between any two cows should have a value greater than or equal to mid. Suppose this condition is true. That means if this condition is true, then for this entire left side, the condition is true. So we will check on the right side. If suppose this condition was not true, if it was false, if it is false, this entire left side is also false. So we check on the right side. So I hope you are getting how to solve the problem. So with the test case, I will show you now. Okay, with the test case example, let me show it to you what I am saying. So test case example is what? 1, 2, 4, 8, 9. What is L value? L value is equal to what? 1. What is H value? It is equal to 9 minus 1. 9 minus 1, which is 8. So let me write it little small. So L equal to 1 and H equal to 8. What is mid now? What will mid be? 4. How many cows I have? 3. So can I place cows in such a way that distance between any two cows is at least mid? If I place one cow here and I cannot place a cow here, so I will place another cow here. I cannot place any other cow, so I can place 2 cows. So for mid equal to 4, I'm not getting the answer. If for mid equal to 4, I'm not getting, for mid equal to 5, 6, 7, 8, I won't get the answer. So I should check on the left side now. So now what will happen? After this, what will happen? After this, my h becomes what? Instead of 8, it will become mid minus 1. And mid was 4. So h becomes 3. I hope you're understanding. My h has become 3 now. Now what is my mid? So let me rewrite L and H. So now my L is equal to 1, H is equal to 3. My mid is equal to what? 2. I need to place cows in such a way that their difference, the distance between their distance is at least 2. Let me place one cow here. Next cow where I will place. Have I made some mistake over here? Just check once. So I hope you're understanding till here what is happening. You can keep your L as 0 also. You will ultimately get the same answer. I have kept my L as 1 because I've kept it as starting. 1 I've taken. So you can keep it as anything you want. I hope everything is correct till here. You are with me. So now we have got mid value as 2. We have placed one cow over here. Can we place another cow here? No. Let us place one more cow here. Yes, we can place a cow here. So we have placed a cow there. Can we place another cow here? Yes, we can place because see, distance between C1 and C2 is what? C1 and C2 distance is 3. It is greater than or equal to 2. 2 is mid, right? That's what we want. Distance between C2 and C3 is 4, which is greater than or equal to 2. We have already placed 3 cows. We can even place, no, we cannot place one more cow. So we can place 3 cows. So for this mid, the answer is true. So we don't check left side. We don't check left side. Where do we go now? We move to right. We move to right side. I hope you're understanding. So let us move to right side. Because we want to maximize the minimum distance. We are moving right side. So L will become mid plus 1, which is 2. And H is equal to what? H is equal to 3. So now what will be the mid value? So the mid value will be now what? Mid value will be equal to 2 plus 3 minus 2 by 2, 2. So here we are getting wrong answer. So why we are getting wrong answer is because we took L as 1 in the initial condition. We should have taken L as equal to 0. If we had taken L equal to 0, we would get it. So actually I told you if you take L as 0, we won't get the answer. Actually we should take L equal to 0 over here. So if we get L equal to 0, then we will end up getting mid as 3. So we end up getting mid as 3, then we will get the answer. Because if mid is 3, I can place cows like this. So let me code and show it to you now. Actually, I had made a mistake over there. I'm sorry for that. L is equal to 0 because our search space is from 0 to a of n minus 1 minus a of 0. That is, this is maximum distance between any two cows. And this is minimum distance. So I was making a mistake over there. I hope you would have rectified me. Tell me in the comments if you had found my mistake before I told you. Please let me know if you did that. So L is 0 and A is equal to, sorry, H is equal to A of n minus 1 minus A of 0. Let us code now quickly. What is the code? So L is equal to 0. So first of all, we have an array and we should sort the array. And H is equal to A of n minus 1 minus A of 0. We will say while L less than or equal to H. Before that, we need to keep answer variable and we need two variables and a count variable. So I will explain it to you. So mid is equal to L plus H minus L by 2. So mid is equal to L plus H minus L by 2. Now we have to write that condition, that check condition. Check condition is what? Can we place cows in such a way that difference between the minimum distance of any two cows is at least mid? So for I equal to 0, I less than n plus plus I. Now how to write the condition? So before this, we have to make count as 0. This will be count of cows. And given input, we have C already. We don't have to bother. This is given. This is given number of cows. Now what should we do over here? Over here, we need to say what? We have to say if A of I minus A of J, J is initially 0, is greater than or equal to mid, we do J equal to I and count plus plus. If we get count as greater than or equal to C, then we have to check on the right side. Before that, let us say answer is mid and L is equal to mid plus 1. Otherwise, we say H is equal to mid minus 1. So this is the condition. Please submit this on Spoj and tell me if you're getting the correct answer. If there is a mistake in my code, please correct me. I will understand that you're watching this completely. You're not just doing, just seeing it. Please do it also. Please do it side by side. You will understand it. I hope you have seen the solution. I hope you have understood what is the concept. Like this only we do binary search problems. I might even be starting another series of only binary search. I will be learning and doing it, okay? But for now, you see, if I'm wrong somewhere, please correct me. I don't think I'm wrong. Just check once. Could you find some mistake in the code? I think you would have found a mistake. Initially, count should be 1. See, every time we are checking this is the check condition, right? Every time we assume at least we can place one cow. Now, if we are placing only one cow, what is the problem? There is no problem. So definitely we can place one cow. That is why count should be at least 1. So that was another mistake I have done deliberately so that you will correct me. Tell me in the comments if you have corrected me again. So if you observed that, please let me know. And thank you for watching this video. Sorry for only one question, but I hope you understood this completely. And next video, we will do other problems. Like, share the video with all your friends. Subscribe to the channel. It really motivates me. You've given me a lot of support till now. Please continue to do so. And we shall not stop. We shall be solving. We shall be learning. We shall be growing. Thank you very much. Have a good day. Take care. Bye. Stay tuned.